Welcome to all of you. Now we discuss MCQ from 2023 Differential Equation and Multivariate Calculus paper CC-7 semester 3 Mathematics Honors University of Calcutta. Question paper 2023 paper CC-7 question 1a. The values of parameters a and b for which the differential equation ax square y plus y cube dx plus 1 by 3 x cube plus bx square into dy equal to 0 is exact are we know a differential equation m dx plus n dy equal to 0. M and n are functions of x and y is said to be an exact differential equation if del y of m equal to del x of n. Comparing the given equation with m dx plus n dy equal to 0, we get m equal to ax square y plus y cube, n equal to 1 by 3x cube plus bxy square. Then del y of m equal to ax square plus 3y square and del x of n equal to 1 by 3 to 3x square plus by square. For the condition of exactness, we get del y of m equal to del x of n. This implies ax square plus 3y square equal to x square plus by square. Comparing x coefficient of x square from both sides, we get a equal to 1, and comparing the coefficients of y square from both sides, we get b equal to 3. Hence the correct option is 3. Next question 1b. The solution of d dxy equal to 1 minus x by y represents what? From the given differential equation, by separating of variables, we get y dy equal to bracket 1 minus x dx. Integrating, we get y square by 2 equal to x minus x square by 2 plus c1. c1 is an arbitrary constant. Then x square plus y square minus 2x minus 2c1 equal to 0. Comparing this with the general equation of this x square plus y square plus twice gx plus twice fy plus c equal to 0 circle, we get g equal to minus 1, f equal to 0 and c equal to minus 2c1. And the center of this circle is minus g comma minus f. So this minus of minus 1 comma 0. So 1 comma 0 is the center. And radius is the root over of g square plus f square minus c, and hence the root over of 1 plus twice c1. Hence the correct option is 1. The family of circle center at 1 0. Option 1. Next question C. Which of the following differential equations is linear? Now linear, here y is the dependent variable unknown function and x is independent variable, and the linear means linear in terms of the unknown function y. Here dy dx linear, but here 2xy square is non-linear because the presence of the term y square. Here dy dx linear, but sin y non-linear term. So this differential equation is non-linear differential equation. And here dy dx whole square, this also nonlinear term. So only correct option is 3. So 3 is the only linear differential equation. A linear differential equation is a differential equation that is defined by a linear polynomial in the unknown function y. Here this is the dependent variable and its derivatives. That is an equation of the form a0 y, a0 a function of x or constant, plus a1 dy dx plus a2 d2 y dx square plus dot 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 plus an dn y dx n equal to bx, where a0, a1, an and b are arbitrary differentiable functions of x or constant that do not need to be linear, and y dash, y double dash, y net derivative are derivatives of the unknown function y of the variable x, independent variable x. And this form for 1 y square is nonlinear term and y square is nonlinear term, and for 2 sin y nonlinear term, and for 4 dy dx whole square is also nonlinear term. So the correct option is 3, is the linear differential equation. Next question, D. The Wronskian of the functions y1 equal to sin x and y2 equal to sin x minus cos x is we know Wronskian W of two functions y1 and y2. This is the determinant of y1, y2, y1 dash, y2 dash with respect to derivative with respect to x. So here y1 is sin x, y2 is sin x minus cos x, and derivative of this y1 cos x and derivative of this cos x plus sin x. After simplifying, we get this equal to 1. So correct option is 2, this 1. Note that this is, since Wronskian not equal to 0, 1, the functions y1 and y2 are linearly independent functions. So here correct option is 2. Next question, determine the nature of the critical point 0, 0 of the following plane autonomous system. X dot equal to 2x minus 3y, y dot equal to x plus 4y. Here dot means differentiation with respect to t, that is dx dt, and this is the dy dt. The given system can be written in the matrix form as the column matrix x dot y dot, and this equal to 2 minus 3 1 4, and this 2 by 2 matrix, and this xy, and that is capital X dot equal to capital A into capital X, where capital X dot is the column matrix x dot y dot, and capital A is the 2 by 2 matrix, this 2 minus 3 coefficient matrix 1 4. And the characteristic equation of the coefficient matrix A, this determinant of 2 minus lambda minus 3 1 4 minus lambda equal to 0. So is the quadratic in lambda, lambda square minus 6 lambda plus 11 equal to 0. Solving, we get by Sridhar formula, we get lambda equal to this. So lambda equal to 3 plus minus I root 2, this is equal to alpha plus minus I beta. Obviously this real part alpha is positive. The eigenvalues are complex number with positive real part, here 3. Hence the critical point 0, 0 is unstable spiral. Unstable spiral. So this is the origin 0, x-axis, y-axis, and this is the unstable spiral. Now here the coefficient matrix is 2 minus 3 1 4, 2 minus 3 1 4, 2 minus 3 1 4. So this is the matrix, coefficient matrix 2 minus 3 1 4. You can adjust by this slide on this coefficient matrix, this A, B, C, D elements, these coefficients, and so this is the page portrait of this. So you can draw this stable, unstable, because from origin this outward, this arrow outward from origin, unstable, this spiral. So you can draw this any page portrait from this website. This is the mathlets.org/mathlets/linear page portrait matrix entry. Unstable spiral. Next question. F. Which one of the following is correct for linear differential equation? This x square minus 3x d2y dx square plus bracket x plus 2 dy dx plus y equal to 0. Now the given differential equation we can write in normalized form: y double dash plus py dash plus q or p2, say this is called p1, this is called p2, p1y dash and p2y equal to 0. So by dividing by x square minus 3x, actually taking common x, so x common, x minus 3, so we get this, the normalized form of this differential equation. Let p1 equal to x2 by x plus bracket x minus 3 and p2 equal to 1 by x into x minus 3. p1 and p2 are analytic functions except at the point x equal to 0 and x equal to 3, because in the denominator these terms x and x, these factors x and x minus 3, presence of this factor, so in the denominator, so this p1 p2 analytic except at these 2 points. Thus all points except x equal to 0 and 3 are ordinary points for the given differential equation. X equal to 0 and x equal to 3 are singular points. Now to check whether it is regular or irregular singular point, consider the product x p1. So x into p1, so x plus 2 by x minus 3, and x square p2, this is the x by x minus 3. Both these products function are analytic at x equal to 0, because there is no x in the denominator of these two products, x p1 and x square p2. So x equal to 0 is a regular singular point of the given differential equation. So correct option is 3. X equal to 0 is a regular singular point. Also note that this x minus 3 p1 this equal to this, and x minus 3 whole square p2 equal to x minus 3 by x are both analytic at x equal to 3. Then x equal to 3 is also a regular singular point of the differential equation. Note that if either or both the products x minus x0, say this sx0 p1 and x minus x0 whole square p2 are not analytic at x equal to 0, then x equal to 0 is an irregular singular point of the differential equation. So here correct option is 3. Next question G. Domain of definition of the function fxy equal to 1 by square root of 36 minus x square minus y square plus log x square plus y square to the base e is what? Now for this part, 1 by root over of 36 minus x square y square, so this term under the square root, this must be greater than equal to 0. So 36 minus x square minus y square must be greater than equal to 0. Otherwise, this term is imaginary or complex. But this is the 1 by, if this term is 0, then 1 by 0, this is undefined. So this term 36 minus x square minus y square must be greater than 0. So x square plus y square less than 36. Next, log x square plus y square to the base z. This log function is defined when this x square plus y square is positive only. So x square plus y square greater than 0. So combining this, we get 0 less than x square plus y square less than 36. So correct option is 3. Next question H. Evaluate this limit, repeated limit, x tends to infinity and y tends to 2, xy plus 4 whole divided by x square plus 2y square. Now this function, let f xy, xy plus 4 by x square plus 2y square. Substituting x equal to 2 here, f x comma 2 is equal to this, we get 2x plus 4y whole divided by x square plus 8. Then the function of x, this is the function of x, and then we find the limit x tends to infinity. So this 2x plus 4 by x square plus 8 dividing by x square on numerator and denominator. So we get 2x by x square plus 4 by x square whole divided by x square plus 8 by x square. So we get this, and x tends to infinity, so 2yx equal to 0, this 4 by x square equal to also 0, 8 by x square also 0, 0 by 1 this equal to 0. Correct option is 2, is 0 answer. Alternatively, you can write, first we divide the x square on numerator and denominator, and we get this, and then taking limit x tends to infinity, so this 0, this 0, this 0, so with 0 by 1 this also 0. So correct option is 2. Next question I. The directional derivative of fxy equal to e to the power x minus x square y at the point 1, 2 in the direction of 2I cap plus j cap is what? Now we know df is the del x of f dx plus del y of f dy is the gradient of f dot dr. So dr is the dx I cap plus dy j cap, and gradient of f is the del x of f I cap plus del f of y j cap. Then the directional derivative of f in the direction of u, so we gradient of f dot u cap, this u cap is the dr by modulus of dr. Now so here del x is equal to e to the power x minus 2xy, this the with respect to x, differential with respect to x at the point 2, 3, 1, 2. we get this equal to e minus 4, and del y of f at the point 1 2 is the minus 1. So gradient of f at the point 1 comma 2 is e minus 4 I cap minus j cap. Next, in the direction u is this 2 I cap plus j cap. So u vector is the 2 I cap plus j cap. So u cap is the u vector by mod of u. So we get 2 I cap plus j cap by root over of 5. So the required directional derivative of this function f at the point 1 comma 2 in the direction of u. So we get gradient of f at the point 1 2 dot u cap. So this e minus 4 I cap minus j cap dot 2 I cap plus j cap by root 5. So 1 by root 5. So e minus 4 into 2 plus this minus 1 into this coefficient minus 1. So we get 1 by root 5. This is the 2e minus 9. So correct option is 2. Correct option is 2. And for interest, what is the directional derivative? Here we have the function e to the power x minus x square y. Let's say here a function is this x square plus y square by 2 at the point 1.5 comma 0.9. So this is the surface. This is the surface, and this is the x-axis. This red color is x-axis, and this green color is y-axis, and this vertically blue color axis is the z-axis. So this is the function surface. This is the surface. This is the function x square plus y square by 2, and the point is this p. P is the point here, and you can change this point by this way. So this is the movement of this point. So according to x and y, so this is the point P. This is the point P. Now vector u. What is the vector u? This is the angle. Suppose this is the angle 0. So when angle is 0, actually this is the point through which the plane, this plane cut the surface. This is the when this u we want to find the directional derivative at an angle 0, at this point at an angle 0. So at an angle 0 means the the angle between the x-axis, positive x-axis, and this u vector is parallel. Angle is 0 is this. If angle is 45 degree, say this is the angle x-axis and this u vector is 45 degree, and this is the corresponding plane. This is the plane cuts the surface along this curve. This is the curve, the result from the intersection of the surface of the function with the vertical plane corresponding to u. This is the vector u vector. Angle for this this is the unit vector u, which we find for angle 45 degree. So this is the this is the plane. This is the plane through the vector u cuts the surface fxy with the vertical plane corresponding to u. Now directional derivative, then the directional derivative is for this point, this f dash 1.4 1.8 is the point, and in the direction u means the directional derivative function fxy at the point p along the direction of the vector u. This is the direction u cap, the direction vector along the u is the slope of the tangent. This is the slope of the tangent line to the previous curve at p. So this is the tangent. This is the tangent. This is the tangent. This is the curve. This curve cuts this surface, this. So this is the slope, this line, tangent line to the curve, this, and slope of the tangent line, this is the directional derivative of the function fxy at the point P in the direction u. So this point 4 is the directional derivative of the function fxy at the point P along the direction of the vector u is the slope of the tangent line to the previous curve at P. So this is the directional derivative is the slope of the tangent, and this tangent is the intersection of the this curve and the surface, this plane and the surface. This is the plane passing through this u vector. This u vector made by x-axis, positive x-axis, in the anticlockwise sense. This is the 45-degree angle. So this is the plane and this is the surface. So this plane cuts the surface along this curve, and this curve for this point P, we draw this projection on the curve, this point, and we draw a tangent line on this surface, and slope of this tangent line to the curve at P is the directional derivative of the surface at the point P in the direction of u. And this you can find from the geogebra.org site. Next question J. For the function fxy equal to 2x to the power 4 minus 3x square y plus y square has a maximum at 0, 0, a minimum at 0, 0, neither maxima nor minima at 0, 0, none of these. To find extrema, that is maxima or minima, first we find del f del x, del f del y, del 2f del x square, del 2f del y square, del 2f del x del y, partial derivatives, first order and second order partial derivatives. Find this. Now for saddle point, we must have this del f del x equal to 0 and del f del y equal to 0. So it is obvious that 0, 0 is the stationary point or critical point of this. Now we find this h, this is the del 2f del x square, del 2f del y square minus del 2f del x del y, this equal to this. Now for this critical point 0, 0, value of h equal to 0. So second derivative test fails. Actually this is we have no conclusion from this second derivative test because this h at the point 0, 0 is 0. So option 4 is correct, none of these. But we now try to find the nature of the surface near about the origin. Along the curve y equal to 3 by 2x square. So if x, 3x square by 2, put this. So obviously minus x to the power 4 by 4 is negative because x to the power 4 always positive. So this is negative, value of this, value of function is negative. And along the curve y equal to 3x square. So this 3x square along the curve we get 2x to the power 4, this is positive. And along the curve y equal to 2x square, this f is equal to 0. Since the function fxy can be both positive and negative or 0, in the neighborhood of 0, 0, it is a saddle point. That means neither maxima nor minima at 0, 0. Now by Desmos f, we draw this graph, this 2x to the power 4 minus 3x square y plus y square. So this is the graph for this. Actually, this is the x-axis, this is the x-axis corresponding, this is the y-axis, and this is the z-axis. So this point origin here, neither maximum nor minimum. This point actually, this is the saddle point. This is the saddle point. This figure, this point 0, 0, and this is the surface, three-dimensional surface of this. So you can draw from the Desmos app this point 0, 0, neither maximum nor minimum, so this is the saddle point. Along this curve, this is the maximum. Along this curve, this is minimum. Thank you for watching this video.